Well, change of pace in today's notes. We're going to talk about number manipulation statements. All of this should go in your notes. Number manipulation statements. These are statements that look like this. I would give yourself a topic here, number manipulation statements. You do not need to write these next things down. But these are problems where it asks you questions like, what percent of 18 is 27? Or 52% of what number is 84? Or what number is 18% of 105? All of these are number manipulation problems where we are trying to figure out, we're dealing with percentages. We're either trying to figure out one of the numbers or maybe figure out the percent. And there's a pretty straightforward way we can take care of these types of problems. We're going to change, first of all, let's talk about percents in general. So example one, this should go in your notes, and really the rest of what we look at will go in your notes. Example one, first thing, let's make sure we know how to change from a percent to a decimal. And example two, we're going to change from a decimal to a percent. So example one, we're going to change each of these percents to a decimal. 18%. 18% change to a decimal. How do we do that? Think through that real quick. To change from percent to a decimal, you take the decimal point, which is right here, 18.0, exactly 18, and we move it 2 places to the left. So 18% is the same as 0.18. Easy enough. 20%. 20%, same thing. We take our decimal point and we move it 2 places to the left. 0.20, or a lot of times you'll just see it written as 0.2. You get the last couple. 108% or 0.2%. 108, we're moving it 2 places to the left. 108% is 1.08. 0.2 is right here. We move it 2 places. Should be 0.002. So to change from a percent to a decimal, move decimal point 2 places left. Example 2 asks us to do exactly the opposite, change each decimal to a percent. Think through how we will do that. If we move the decimal point 2 places to the left to go from percent to decimal, to go from a decimal to a percent, so I'm going from 0.18 and I want to get to 18% now, doesn't make sense. We're going to move the decimal point 2 places right. Move the decimal point 2 places to the right. So 0.28, 2 places to the right, we get 28%. And so on. Think through each of these. %125%, 0.03 is 3%, 0.009, decimal point is there, 0.9%, probably should have had one that looks like this also. If we have 0.7, should be 70% in that case. So 0.7 is 70%. So we should be able to change from a percent to a decimal or a decimal to a percentage pretty quickly. That hopefully isn't anything new. Going back to these number manipulation statements, what we want to do is when we see something, we want to write down within a numbered equation, we want to write something down. So anytime you see the phrase what number or what percent or just what, that's what we're looking for. That should be a variable. Usually we'll call it X. If you want to call n for a number, that's fine also. But we need to put a variable in when it's asking what number. So when you see what percent, you would put an X in there. The word of. Notice the word of occurred in each of those statements previously, each of those number manipulation statements. The word of is telling us to multiply. So if it says 12% of what number, you're going to take 12%. We'll talk about what to do with that in a moment. Of what number, so it's going to be times X. The word is, if you see the word is, you put an equal sign. And if it gives you a percent, I think I just said 12%, we are going to rewrite the percentage as a decimal. Within our numbered equation, that percent needs to be a decimal. So directions here, each of the following examples, we are asked to solve the problem, and we are going to round to the nearest tenth or the nearest tenth of a percent if it's asking for a percentage. So example one asks us what percent of 39 is 14? What percent of 39 is 14? So we write our equation the same way that we read it here. What percent? What percent? Okay, that's what I'm looking for. I don't know what it is, so we're going to call that a variable, X. The word of tells us we need to multiply. 39 is, we put an equal sign. Basically, we're saying we want this to be the same as that, so equals 14. X times 39 equals 14. We're solving for X, so we need to undo that multiplication, which we do by dividing both sides by 39. We get 14 over 39. It told us to round. So if we are being asked to round and divide these, you would be allowed to use a calculator here. 14 over 39, 0.35897, 0.35897. And there's more after that. It wants a percent. We wrote it as a decimal here. We can change from a decimal to a percent. We just reviewed how to do that by moving the decimal point 2 places to the right. So I get 35.897%. And then it tells us to round to the nearest tenth, or in this case, tenth of a percent. So tenth is one place after the decimal point. That 8 needs to be bumped up to a 9, 35.9%. Example 2. Example 2, 22% of 84 is what number? 22% of 84 is what number? Anytime we see a percent, we're given 22%. We need to write that as a decimal here. To change from a percent to a decimal, the decimal point moves 2 places to the left. So I get 0.22. Of means multiply. Use parentheses this time. 84 is, I put equals, what number? I don't know what that number is. We call it a variable. I'm calling it x. So to get x this time, I'm just taking 0.22 times 84. We get 18.48. Generally, I'd like it because it's exactly 18.48. I would not round, but the directions did tell us to round to the nearest tenth, so we probably should. To the nearest tenth, 18.5. It'd be smart to kind of make sure our answer is reasonable here. 22% of 84, well, it needs to be smaller than 84. And it's well less than half of 84. Half of 84 is 42. Yeah, that makes sense. Example 3. Example 3 says 156 is 92% of what number? 156 is 92% of what number? $156 is, I put equals, 92% needs to be changed to a decimal. Decimal points here. To go from percent to decimal, I move it to the left. 0.92 of means times what number? We put in x. 156 equals 0.92 times x. I need to get x by itself, so I am dividing both sides by 0.92. 156 divided by 0.92. 169.565. Whoops. Rounded to the nearest tenth would be 169.6. What I want you to do right now, we have numbers 4, 5, and 6. You are going to do these. So somebody pause the video, and then once everyone has finished the problems on your own, you can restart the video, and it'll show how to find the solutions. So number 4, what x is equals 123% as a decimal is 1.23 of, I put times 48. 1.23 times 48 is 59.04. I did it again. What did I say? 59.04. Again, because it's exactly that, I like that answer, but it did tell us to round to the nearest tenth. 59 point, so this 4 makes us round down to a 0. Usually you would include the 0 here just to show we have rounded to the nearest tenth, 59.0. Question number 5. 72 is what percent of 50? 72 is what percent of 50? 72 is, I put equals what percent? I'm looking for that. That's my x of means times 50. To get x by itself, we divide both sides by 50. X equals 72 over 50, 1.44. And double check, I'm looking for a percentage here. I have it as a decimal. We do need to change it to a percent. Move your decimal point 2 places, 144%. 144%. Make sure your answer makes sense. Had we left it as 1.44, 72 is 1% of 50. That's 1% of 50 would be super small. 1/2. 144%. It's more than 100% because it's bigger than 50. It's 100% of 50 plus 44% more than that. Hopefully you can see that light pink. Number 6, question number 6. 90 is 40% of what number? 90 is equals 40% as a decimal is 0.40 or just 0.4. Of means times what number I put in x. To get x by itself, we divide by 0.4. 90 divided by 0.4 is 225. Uh, 90 is 50% of 180. So yeah, 40% of something bigger. That makes sense. That is it for the notes today. You have problems to work on as well. Check Google Classroom.